Okay, our next speaker focuses in his presentation on emission reduction measures and their socioeconomic implications. Aleksejs Nipers is the next speaker, moving towards the stage. Welcome.
Hello, everybody. Everything works. Yep, nice. So, my today's presentation is as part of this project. We evaluated what is the impact of different measures from socioeconomic perspective. And today I am presenting, but we are a team of researchers which work with this task. So let's start with a topic that actually how we use our land. It's quite diverse, and it looks diverse from the perspective of how it's landscape. It very different what we are growing on this land. It's very different what is type of soil. So there are very much differences between. And if you look at the landscape, you can see there are forests, there is arable land, there is grassland, there is abundant land, but how much we are as landowners and we as a society are getting from different type of land and land uses. So that's the question actually which we should answer if we want to answer the whole topic of our research. And the difference could be quite significant because from forest perspective, forest is accumulating carbon. From arable land, you can get more profit and there is employment over there. From abundant land perspective, it's again maybe a little bit better from the perspective of greenhouse gas emissions, but there is no much economic benefit. So there are quite significant differences, and difference also if you are looking at arable land, it depends what you are growing on this land. If you are growing just cereals, then that's one situation. If you are growing vegetables, that's totally different situation from socioeconomic perspective. So our tool is a tool which is data driven and it is created for policy planning and decision making perspective and for decision making, and it allows to calculate the impact of different measures on regional and national level. I will explain in the next slides what does it mean, but the overall idea is to look at land and different measures, not only from this perspective how much we are reducing greenhouse gas emissions or how much we're sequestrating carbon, but also what are socioeconomic implications. Are there some associated impact on profitability, and are there any impact on employment? And for this task, our tool is also created. What we did is we can split in 5 steps. First, we gathered a lot of information, data, how agriculture and forest land is used in the Baltic region. After that, we collected data for organic soils. We generated some working files to see where we can implement measures which are already presented in the first 2 presentations. And after that, we made the calculations to see what is the impact. So to visualize what we have done, it's, for instance, here we mapped everything for the 3 Baltic countries, where is agricultural land located, very specifically, parcel by parcel. We mapped forest land, where it is located. So we have information about productive land use. After that, we also got the information about organic soil, where is geographical organic soil located. But from this, we also excluded areas which are protected areas from biodiversity perspective, because there's assumptions that we can't implement measures on land on which there are restrictions that you can change land use for those specific parcels. So after that, with a simple math, we gathered information. We made a sum of agriculture and forest land and made an overlap with organic soil, excluding protected areas. So we got a layer of information on which we can implement, theoretically, we can implement all the measures which are already presented in the first two presentations of this session. So, but here is different type of land. There is forest, here is agricultural land, there are grassland here, there are cereal productions, for vegetable production, so there is quite diverse. And for this reason, we also calculated per each parcel as a baseline scenario what we are getting from each specific parcel. And that is three perspectives. That is profit, how much profit we are getting currently per each parcel. That's how much employment we are creating at each parcel, and how much emissions on sequestration are happening per each parcel. For greenhouse gas emissions, profit and employment, we used calculations before implementation of the measure, after implementation of the measure, or difference. So for greenhouse gas emissions, we just took information which were prepared in the other work packages and already presented here. And there's a difference between before implementation of a specific measure and after. But we also calculated some algorithms to calculate what is profitability before and after implementation of each measure. And the results are calculated for 2 time points, that is for 2030 and for 2050. As an example here, it is like if we look at employment creation before, and for agricultural land, we have specific number of hours, how much hours it is needed to different agricultural activities. For instance, if it is for potatoes and for medium-sized farm, it is 165 hours per hectare. If it is small farm for grain production, it is typically 24 hours per hectare, and etc. So we pre-calculated some specific indicators. It's a little bit more complicated for profitability, but that's kind of information we had for calculations. It is a little bit more complicated for forestry, because for agriculture, its production cycle is typically short. In many cases, it is just for 1 year, but for forestry, it is quite long period. And it should be noted here that when we are calculating for 2030 and 2050, so we are calculating what's happening in that specific year. And when we are calculating for 2030, there are some parcels for which we calculated seeding, planting, tending, and for 2050, that's typically for some parcels for pre-commercial thinning, and harvesting was not actually included for afforestation measures, for instance. So the results looks like it is here. So for the first scenario is conversion of cropland to grassland. So we mapped everything which could be on which land it could be implemented, this specific measure. And here is descriptions. There is criteria how we selected. So we select organic soil, arable land without perennial plantations. That's maximum possible area on which we can implement this measure. And after implementation of this measure, this will be just a grassland. So the area is maximum of the possible area. And here we can see also a small graph, how it is distributed, how much it is in total in Estonia, in Latvia and Lithuania. And the same kind of exercises we also made for other scenarios. For instance, here is a forestation scenario, and the same. We have a description, what is done, area selection before and after implementation of the measure. So in this case, organic grassland, perennial grassland, arable land without perennial plantations are becoming forest land dispersed. So how it looks. And this kind of exercises are done for almost each measure. And you can see that visually also that differs country by country and measure by measure. I will not go through each of them, but here is a kind of summary what we can get. Here also the list of all the measures, and for each measure we can see the impact and split of the impact between 3 countries. And we can see that the largest impact, and here is greenhouse gas emissions, so negative impact is a positive thing. We can see that 3 scenarios, 3 measures have significantly higher impact, and that's afforestation, conventional afforestation, that is forest polyculture, and agroforestry. And we can see also that in Lithuania, the overall impact is higher than, for instance, in comparison to Estonia. And we can also see that due to the area on which we can implement all the measures, some of the measures have quite insignificant impact. So we should take into consideration. And after that, we also calculated on profitability, and you see the picture is totally different. Some measures we have positive impact on profitability, so landowner, land user can get more money by implementing these measures. For some measures, there will be negative profit. That means they are going to lose some money. And the picture you can see here. I will not go very much into details, but you can see that our overall conclusions that agroforestry has the most positive impact, and introduction of forest polyculture is with negative impact. That means that if you want to implement them, it should be quite substantial kind of support for public support. Impact on employment is the third and the last thing we also calculated, and we can see again that there are a couple of measures with quite significant negative impact on employment. Employment is calculated in full-time equivalents here, and afforestation and forest polyculture has the biggest impact, and is typically associated that agriculture in general has higher labor input necessity to produce something in comparison with forest, which is not so labor intensive, especially taking into account that we are calculating for 2030, 2050, so the final harvesting is typically not included in this lifetime. So all the things take into account that there are many different scenarios, and for couple of time periods are also included in simulation tool, when you can interactively also select and see the result, and it's changing. Green is positive, red is negative, and it's available on the homepage. I think it will be included in our Orgbalt homepage, so everybody will be able to click and to see what are the results. Thank you.
All right. This is one of the presentations where the end comes suddenly. Wasn't it so? I mean, but it's good. It's good. Do we have Slido questions? Can we see them? Yes. So not that many, so no choosing, just addressing all of them. Okay, with you? So what were the most challenging aspects to be included in this evaluation of the impact of these different measures?
What are the most challenging
aspects to be included in this evaluation?
The most challenging, definitely, it is like we have to calculate something in general, but at the same time, per each land, per each land parcel, the situation is quite different. So where it is located, who is managing that? So there's quite a big diversity of how profitable is land use. But so we have to generalize and at some point to put some average figures with some assumptions. So that's the most, I guess, the most challenging thing. And another challenging thing to gather all geographical information which is needed for the model.
All right. Kaido is asking about conventional afforestation, which is spruce. Could it be possible that by 2050, those trees won't survive due to climate change? For example, bark beetles attacks.
Again, I guess forest experts which included these measures, first of all, will be better situated to answer this question. But I think that there are some risks, definitely. Is the climate risk the biggest risk? But yeah, it should be also considered during when we are preparing some recommendations. There are some risks and some probabilities that it will not happening this way, and some area will be on some area will not achieve the expected results.
Kaido, what do you think? I mean, about your question?
Well, I'm afraid that it won't last that long.
Yeah. So yeah, Kaido is saying that they might not last that long. I mean, that question kind of contained the answer, I believe. Okay, good. Just guessing, yeah, we'll see. I mean, it's easy to guess such far away future because nobody would actually remember your projection. I mean, it's quite convenient. All right, next. Is the impact for 2050 for all scenarios and all countries calculated, taking into account whole potential area for measure to be implemented? I didn't get it as well.
No.
Let's skip it. Were all protected areas excluded from the calculation regardless the protection level? For example, from strict protection to virtually none?
No, there are different levels of protection, definitely, and what we included is that we cannot change land use. So we can convert one type of land to another type of land. That's included in the protection area. So it's gathered very specifically, this information for per each parcel, and that's what included. In real situations, it will be changing, some areas changing year by year, but I think that overall picture is captured by this.
It's always full screen of questions. Where do you get them from? I mean, we can't cover all of them.
I guess Kaido is adding.
Kaido is the one. All right, so the last one, most popular, is the simulation model to be peer-reviewed and published in a journal?
Definitely it should, and it will, yeah.
When?
I take into account that there are typically up to 1 year revision and reviewing, so it could be
a year from now.
Yeah,
about plus minus 3 years. I mean, we'll see how it goes.
General error.
All right, thank you, Aleksej, so much. Thank you.
Thank you.
Okay, now this is fun. I love it.